In this video, we look at another Euclidean geometry question, and as always, I encourage you to pause the video and attempt the question on your own, and then when you're done, you can play back the video and see how you fared and compare your solution against mine. So I'll give you a couple of seconds to do that. Welcome back. So in this diagram below, we are told that triangle ABC is drawn with D and E points on AB and CB respectively. M is a point on DB, so M is that point on DB. DE is parallel to AC, so this line DE is parallel to AC, and you can see we've got those lines showing that it's parallel. Also, the line AD is equal to DM, which is equal to MB. Okay, so all those portions are equal to each other. The task here is to show that the ratio of E to C, this ratio E to C divided by B to E, is going to be, well, that's what we're required to calculate. So we are told that all these are equal, so we don't know what the length is going to be is. So I'm going to assume that this is equal to K units, and that's also equal to K units because they are all equal to each other. But we know that EC over BE, okay, so this length here, E to C divided by B to C, is going to actually equal A to D, because it corresponds to EC, so I'm going to say it's equal to AD divided by DB. Okay, well, we need to give a reason for that. It's because of a line that is parallel to the third side of triangle ABC. Okay, so once we have that, it should be downhill. So EC over BE is going to be equal to AD. If you ever look at AD, it's just 1 K unit, and DB is that distance there. It's got 2 of those K units, so it's divided by 2K. So EC over BC is actually just equal to 1 over 2. In part B of the question, we're required to calculate the area of the triangle BME. I can suggest that you take a highlighter and highlight the triangle that you're looking for. So BME, the ratio, divided by the area of triangle BAC. I'm going to use a different colored highlighter there. We're looking for BAC, so BAC, that whole triangle there is what we're going to try and do. You can notice that the two triangles actually share this angle B, and if they do share that angle B, it's easier to calculate, and we don't have the lengths. So let me take a step back there and say that by making use of this theorem, proportional division theorem, where we have a line that is parallel to one side of the triangle, and we've worked out the ratio, so we know that the ratio E to C is going to be equal to 1 over 2. So let me suppose that this length is actually equal to P units, then that length B to E, the length B to E, this one here, is going to be equal to twice that. So it's going to be equal to 2P units. Okay, so I've said that they share the same angle B, this angle here. So the area A of triangle BME is going to be equal to 1/2 times this distance here. You see that distance BM. That distance BM is going to be equal to K units, so we're going to multiply that by K units, multiplied by the other side of the triangle BE. So for that green triangle, it'll be BE. Well, we just worked out that that's going to be equal to 2P units. So it's going to be times 2P units multiplied by the sine of angle B. making use of the area rule for the triangle. If you're unsure of this, just need to brush up on it, where we say that the area of a triangle is going to be a half AB sine of theta, where A and B are the sides that make up the angle theta. So in this case, the angle theta is equal to B units. All right, and that we're going to divide by the area of triangle BAC. Okay, so similarly, I'm going to say it's going to be equal to half of the triangle BAC. If you have a look, that side that makes up angle B is equal to 3K units. So we're going to say multiplied by 3K multiplied by the other side. This other side here, if you have a look, it's 2P plus 1P. That's going to be equal to 3P units times by sine of the angle B. Okay, so from here you will notice that this is a constant. It cancels out with that one. This 1K will divide there once, there to divide 3 times. So I'm just reducing this, and then the P will cancel out with that P, and the sine B cancels out with the sine B. So ultimately the required ratio is simply going to be equal to 2/9. Okay, I hope you had some success in those two parts of the question. Okay, so the third part of the question says, if the length of DE is equal to 17 units, find the length of AC. I think we got a bit of clutter there, so let's just take out some of this highlighting. And so we are looking to find the ratio of the side AC, so the line AC divided by, no, that's the length we're looking for. But we know that this triangle is using the proportional division theorem, using the same theorem that we used here, we will know that the ratios of the corresponding sides are going to be equal. So I will say AC divided by DE must equal the sides, the corresponding sides. I could say there that AB divided by AD. Sorry, that's not AD, it's going to be BD, so it's from the smaller triangle. So if you take a length from the longer triangle, and then you take a length from the smaller triangle, this one, BD, so you can see BD is 2K units. So I'm going to say that AC over DE is going to be equal to 3K, that's AB, divided by let's see, AB divided by BD. Sorry, here we wanted to say it's got to be divided by BD, and BD is equal to 2K units. So here you need to say line parallel to third side of the triangle ABC. Okay, so then the ratio of AC divided by DE is going to be 3/2. But we are given that DE is equal to 17 units. So AC is going to be, and this cancels out, 3/2 multiplied by DE. And we've just said that DE is equal to 17 units. So I'm going to replace that with 17. And that's going to give us 25.5 units. And so that's the length of DE. And this question is typically for 4 marks in an exam. And so let's have a look, see where we would be allocated marks throughout those 3 questions. So here you'll get 1 mark for that statement and another mark for that one there. Let's see, making use of the ratio to get a final mark there. So 1 mark for the answer, and I'll give you 1 mark for there and a mark for the other one, and just 1 other mark for making sure that you used this area rule. Okay, and finally for this one here, I'll give you a mark for the statement, the final mark, and realizing that you can set it up into that and substituting the formula. Okay, I hope you had some success in that one.